All right, guys, let's knock out this practice test 26. Get you ready for tomorrow. First two. Find each of the following to 4 decimal places using a calc. Just punch in. Remember, your E button is right above your LN. Hit second LN, hit the 3, and it should come up. Remember, 4 decimal places. So I'm going 20.08554. Actually, that's 5 decimal places, which is too many. So that's good enough. Number 2, punching in again. Open a parenthesis. Just do exactly what you see. 1 divided by hits your E button, the 4th power. Get out of there, close your parentheses, square it. Make sure you're squaring the whole parentheses. And I'm getting an E. I'm getting a 3.3546 with the E -4. That E -4 means you move the decimal back 4 places. So 1, 2, 3. The first three that you see should be the 4th place after the decimal. So, and that's 4 decimal places. So you can stop right there. Pretty neat. Okay, number 3. Graph this thing. F of x equals 3 to the x power. Draw your asymptote. I need to see your asymptote and your 2 points. And because there's nothing with this one, it's just plain old 3. The first point's above the 1. To find the second point, go 1 to the right, which is at 1. If you plug a 1 in there, 3 to the first power is 3. So I'm going to put a point at the 3. The graph is going to go just like through there. That's all you got. Now, my graph didn't show up for number 4, so I'm going to have to erase this real quick to number 4. There we go. Number 4 says it's the same thing, except it's 1/3 to the x, which is reciprocal, which is decay, which means the graph's going to go down instead of up. There's no shifts in this one, so the asymptote's still right there on the x-axis. Still have a 0.1 above. That's 2 points, a little too big there. Now, go 1 to the right. If you go 1 to the right, you get 1/3 if you plug in 1 for x, which is like way down there at 1. So the graph should go like this. Make sure I can see your 2 points there, and you're good to go. 2 more of these. Number 5. Number 5 has a number in the front, which is a vertical stretch. Okay, that doesn't affect your asymptote at all, so the asymptote is still right here on your x-axis. It does affect everything else. All right. Usually I put a 0.1 above, but because it's been stretched by 4, and what a vertical stretch does is it multiplies all your y coordinates by 4. So if the y coordinate's usually 1 times 4 is 4. It's up here now. Now if I plug in 1 right there, it actually becomes -1 because of the negative sign. Take your calculator, punch in 4, hit your E to the -1 power, hit enter, and I'm getting 1.47, almost 1.5, which is about right in there somewhere. So that graph should do something like this, getting closer and closer to the asymptote. Number 6, first one we've had with this shift in it, it's got a -2. That -2 shifts your graph down 2. So I'm going to go down 2 right here. There's no left or right shift, so the first point, there's no vertical stretch. First point's up on 1. 1 above the asymptote, I should say. And then to get the second point, go 1 to the right. So I'm going to plug in 1 for x. And if I plug in 1 for x, I'm going to get 3 minus 2. 3 minus 2 is 1, which is right there. Connect the dots. La, la, la. And there you have it. Hopefully, those first 6 for you guys are just like, that's not bad at all. At least I hope. Number 7. Number 7 is down here. I didn't even see it. Okay, here we go. Use the critical values to solve the inequality. There's only one critical value because remember, on your line down here, you need to put everything that makes your numerator and the denominator 0. Well, you can't make 1 become 0. So the only thing you got is your denominator, which is 3. Plug in 100. If I plug in 100, I get 1 over 97, which means everything over here is positive. Everything over there is negative. And because it says greater than 0, that means I'm looking for positives only. Where's the positive? It's everything past the 3. And I'm going to go 3 to infinity. That's going to be my answer. Because there's no equal sign, that's why I use parentheses there. I forgot. Number 8, find the inverse if you miss this one. Yeah, so just remember, the definition of inverse is your x's and y's interchange. They just switch. So that's all you do on number 8. Can I do that on there as a give me for you guys? You're welcome for that. Number 9, determine whether it's 1 to 1. So first of all, plug it in your calculator. See if it passes the horizontal line test, if you need to. This is a slope-intercept form. It's a line with slope 4, which will look kind of like this. Well, I'll try to draw it. Look kind of like that, which means, it does pass the horizontal line test. So then it says find the inverse. So switch your x and y's. Move the 9 over. Divide by 4. And when you divide by 4, you're going to have the y by itself. Remember, when we get the y by itself, we're going to write it with the f -1, the inverse notation, which would be x minus 9 over 4. And number 10, 10 says find a polynomial function of degree 5, so you got to have 5 x's. With 1 as a 0, multiplicity 2. So don't forget your p of x. Come on, guys. Put the p of x there. Show this a function. 1 is a 0, multiplicity 2, so I'm going to put x minus 1 squared. 0 has a 0, multiplicity 2, so I'm going to put x squared. You don't need to put x minus 0. And then negative 1 is a 0. Negative 1 would be x plus 1, but it just has multiplicity 1. So there you have it. Number 11, divide using synthetic division. The 2 is going to go in the box. The key to this one is putting all your zeros in there. You got x to the 5th, you don't have x to the 4th. You got x cubed, you don't have x squared. You got x to the 1st, you don't have a constant. Okay, so now it's just a matter of going through your process here. Bring the 1 down first, multiply by what's in the box. 1 times 2 is 2. Add them up, multiply by what's in the box. Add them up, multiply by what's in the box. Add them up, multiply by what's in the box. Add them up, multiply by what's in the box. Now don't get so excited you did that you forget to write your answer. We began the problem with x to the 5th power, which means our quotient is going to start with x to the 4th power. So I'm going to have 1x to the 4th, 2x cubed, 6x squared, 12x, 21, and then 42 is my remainder. Put that back over the x minus 2, and you got it. Number 12, describe the end behavior. Find the degree. Remember, the degree is the biggest exponent. Don't look at the first one. Look at the largest one. The largest one's 8, which is even because it's negative. Remember, even, it goes both up or both down. Because it's even and negative, they're both going down. So the left side's going down, and the right side's going down. That's what we got there. Number 13, solve this problem. I'll keep putting this on there, guys. Eventually, you're going to get it. We'll see what happens. So move the 1 over. Some more people did get it last week, I must say. You're getting there. I need everybody to get this. So state the radical, square both sides. This is the part where most people miss it. If you square the left-hand side, the radical just goes away. If you square the right-hand side, you do square, multiply together, double, square. Now, once you get there, because I have an x squared, you need to factor, or try to factor. So I'm moving everything over to the right-hand side. If I move the x over, it becomes minus x, which gives me minus 3x. Now the 1s, if I move that 1 over there, they're gone. So all I have is x squared minus 3x. The first thing you do when you start to factor always is you look for that GCF. So take out the x, leaves x minus 3. So I get these two answers. Maybe I get 0 and 3. All right, if I plug in 0 up there, it'd be like 0 plus 1 plus 1 is 0. There's no way 1 plus 1 is going to be 0. Okay, somebody just walked in right there. So finishing this up, plug in the 3. If you plug in 3, you get this. You get 3 plus 1 inside. Plus 1 is 3. 3 plus 1 is really 4 inside there. Square root of 4 is 2. Plus 1, that is 3. That's true. So 0 did not work. 3 did work. We're good. Now remember, both answers could work, or neither one could work. Who knows? You got to test them out. All right. So hope it helps. Hope you do great tomorrow. See you then. Come see me if you need some help. See ya.